And what if I told you that the universe itself might have a preferential direction, a secret axis that challenges everything we thought we knew about the cosmos? That there's something out there so unsettling for modern cosmology that scientists literally dubbed it the axis of evil. Get ready, because today we're going to explore one of the most controversial discoveries in modern astronomy. One that might be rewriting the fundamental laws of the universe right this very moment. Hello, cosmic explorers. Welcome back to Cosmic Frontiers, where we unravel the most fascinating mysteries of the universe. Today, we're diving into something that's keeping cosmologists up at night. The mysterious alignment of the cosmic microwave background radiation and what it means for our understanding of the cosmos. By the end of this video, you'll understand why a seemingly technical discovery might be signaling that we live in a much stranger universe than we ever imagined. And of course, we continue our journey towards 1,000 cosmic explorers, building together a community passionate about the universe's secrets. To understand the axis of evil, we first need to go back in time, to the first moments after the Big Bang. Imagine the universe as a cosmic pressure cooker that just exploded. In the first 380,000 years, the cosmos was so hot and dense that light couldn't travel freely. It was like trying to see through a thick fog. But then, something magical happened. The universe cooled enough for the first atoms to form. And for the first time in cosmic history, light could travel freely through space. This first light is still out there, traveling through the universe for over 13 billion years. It's like the oldest echo of the cosmos, a photograph of the baby universe. Scientists call it the cosmic microwave background radiation, or CMB. Think of it as the Big Bang's fingerprint, carrying precious information about what the universe was like when it was just a tiny fraction of its current age. For decades, cosmologists expected this radiation to be completely uniform in all directions. After all, if the universe began with a big explosion, the energy should be distributed equally in all directions, like waves spreading uniformly in a lake after we throw a stone. This uniformity was one of the fundamental pillars of what we call the cosmological principle, the idea that the universe is homogeneous and isotropic, meaning the same in all directions. But the universe, as always, had a surprise in store for us. When the WMAP satellite, launched by NASA in 2001, began mapping this radiation with unprecedented precision, scientists discovered something completely unexpected. The cosmic microwave background radiation wasn't perfectly uniform. There were patterns, structures, and even more disturbingly, these patterns seemed to be aligned in a way that simply shouldn't exist. Imagine you're looking at the clouds in the sky and suddenly notice that they're all perfectly arranged in rows pointing in the same direction. That would be strange, wouldn't it? That's exactly the feeling cosmologists had when they analyzed the WMAP data. The temperature fluctuations in the cosmic microwave background radiation, those small variations that would eventually give rise to galaxies, seemed to have a preferential orientation in space. More specifically, scientists discovered that some of the largest structures in the CMB were aligned with what we call the ecliptic plane of the solar system, the plane in which Earth orbits around the Sun. To understand how bizarre this is, imagine you're in a gigantic football stadium, with 100,000 people shouting randomly. Suddenly, you notice that the noise isn't random. There's a pattern that's perfectly synchronized with the rhythm of your breathing. That would be an impossible coincidence, right? It was precisely for this reason that scientists, with a touch of dark humor, christened this discovery the axis of evil. The name has nothing to do with malevolent forces, but rather with the fact that this discovery was so unsettling for established cosmology that it seemed almost devilish. It was as if the universe was mocking our most fundamental theories. Kate Land and Joe Maguire, the cosmologists who first identified this pattern, were so surprised that they spent months checking and rechecking their calculations. They knew they were facing something that could revolutionize our understanding of the cosmos. The problem is that, according to our current theories, there simply shouldn't be any special direction in the universe. It's like discovering that there's an up direction in space, when we know that in the cosmos there's neither up nor down. But the story gets even more intriguing. When the Planck satellite, WMAP's more advanced successor, began its observations in 2009, scientists hoped this anomaly would disappear. Perhaps it was just a measurement error, an artifact of the instruments, or some contamination in the data. But Planck, with its even greater precision, not only confirmed the existence of the axis of evil, but also revealed that the phenomenon was even more pronounced than initially thought. To give you an idea of the precision of these measurements, Planck was able to map temperature variations in the cosmic microwave background radiation with an accuracy of millionths of a degree. It's like being able to measure the temperature difference between 2 drops of water in an Olympic swimming pool. And even with this incredible precision, the mysterious alignment persisted, defying our explanations. So, what exactly are we seeing? The axis of evil manifests primarily in what scientists call the Lauder multipoles of the CMB. Without getting into complex mathematical details, this means that the largest visible structures in the cosmic microwave background radiation, those that extend for billions of light years, show a statistically significant tendency to align with certain directions in space. It's important to understand that we're not talking about a perfect alignment like soldiers in formation. It's more subtle than that. Imagine you're rolling dice thousands of times and you notice that, statistically, certain numbers appear more frequently when you roll the dice in a specific direction. Individually, each result seems random, but when you analyze the overall pattern, there's clearly something non-random happening. Now, let's explore the possible explanations for this phenomenon, and this is where things get truly fascinating. The first possibility, and the most conservative, is that we're dealing with some kind of systematic contamination in the data. Perhaps radiation from our own solar system, or the Milky Way, is creating this artificial pattern. Scientists have spent years trying to eliminate all possible sources of contamination, but the signal persisted. A second explanation involves what we call observational selection effects. Since we are observing the universe from a specific point, Earth, it's possible that our particular perspective is creating this apparent alignment. It's like being inside a house and trying to understand the architecture of the entire neighborhood by looking only through the windows. Your limited perspective can create patterns that don't exist in reality. But there's a third possibility, much more radical and exciting. The axis of evil might be telling us something fundamental about the very nature of the universe. Perhaps the cosmos isn't as uniform and isotropic as we thought. Perhaps there really is a preferential direction in the universe, a fundamental asymmetry that dates back to the first moments after the Big Bang. One of the most intriguing theories suggests that the universe might have a non-trivial topology. Imagine that the universe isn't like an infinite sphere, but rather like a gigantic donut, or an even more complex shape. In this case, the light from the cosmic microwave background radiation could be traveling around the universe and returning to us from specific directions, creating these alignment patterns. It's as if we're seeing multiple images of the same primordial universe, reflected by the cosmic edges. Another fascinating possibility involves string theory and extra dimensions. According to some versions of string theory, our three-dimensional universe might be embedded in a higher dimensional space. If there were asymmetries in these extra dimensions, they could manifest as preferential directions in our observable universe. It's as if we were two-dimensional beings living on the surface of a soccer ball. We wouldn't be able to see the third dimension directly, but we could detect its effects through patterns in our two-dimensional reality. There are also theories that suggest the axis of evil might be evidence of physics beyond the standard model of cosmology. Perhaps there are fundamental fields or forces that we haven't yet discovered, which were active during cosmic inflation, that period of exponential expansion right after the Big Bang. These fields could have created preferential directions that were imprinted on the cosmic microwave background radiation as a permanent signature. One of the most audacious proposals comes from cosmologist Joe Maguire and suggests that the fundamental constants of physics themselves might vary with direction in space. Imagine a universe where the speed of light isn't the same in all directions, or where the gravitational force has slightly different intensities depending on the orientation. It would be like living in a world where the rules of physics subtly change as you move or look in different directions. But perhaps the most revolutionary explanation is that the axis of evil is evidence that our universe is not unique. Some multiverse theories suggest that our cosmos might be gravitationally interacting with other parallel universes. If these other universes were organized in a specific way in hyperspace, they could create preferential directions in our observable universe. It's as if we were a soap bubble in a cosmic bubble bath, being influenced by the position and movement of the other bubbles around us. It's important to mention that not all scientists are convinced that the axis of evil represents something fundamental about the universe. Some argue that it might simply be a statistical fluctuation, something rare but not impossible, that can happen by chance even in a perfectly isotropic universe. It's like winning the lottery, extremely improbable, but not impossible. However, as more data is collected and analyzed, the statistical significance of the axis of evil continues to grow. The probability that it's just a coincidence is becoming increasingly smaller. It's as if we were winning the lottery repeatedly. At some point, we have to consider that it might not just be luck. What makes this discovery even more intriguing is that it's not isolated. Other anomalies in the cosmic microwave background radiation have been discovered, including what scientists call the cold spot, an inexplicably cold region that is much larger than should be possible. According to our current theories, these anomalies might be connected, suggesting that we are seeing evidence of fundamental physics that we don't yet understand. The implications of the axis of evil go far beyond theoretical cosmology. If there really is a preferential direction in the universe, this could affect our understanding of how galaxies formed and evolved. It could explain why certain cosmic structures seem to be organized in unexpected ways. It could even have implications for the future of the universe and its ultimate destiny. Imagine if we discovered that the universe has a fundamental current, like a cosmic river, that flows in a specific direction. This would completely change our perspective on our place in the cosmos. We would no longer be inhabitants of a perfectly symmetrical and democratic universe, but rather travelers on a cosmic journey with a defined direction. The search for answers continues. New telescopes and satellites are being developed to study the cosmic microwave background radiation with even greater precision. The future James Webb Space Telescope and other next-generation instruments may provide crucial clues to solving this mystery. Every new observation brings us closer to understanding whether we are truly seeing evidence of new fundamental physics, or if the axis of evil is just an elaborate cosmic prank. What we know for sure is that the universe continues to surprise us. Every time we think we understand the rules of the cosmic game, we discover something that forces us to rethink our most basic assumptions. The axis of evil is a humbling reminder that, even after centuries of scientific progress, we are still explorers in a vast and mysterious cosmos. So, cosmic explorers, we've reached the end of our journey through the mystery of the axis of evil. Recapping the most fascinating points, we discovered that the cosmic microwave background radiation, our window into the primordial universe, shows a mysterious alignment that challenges our fundamental theories. We saw that this phenomenon could be evidence of new physics, of extra dimensions, or even of other universes. And we learned that, sometimes, the most important discoveries come from anomalies that initially seem like errors. This discovery reminds us that we are part of something much larger and more complex than we can imagine. If there truly is a fundamental axis in the universe, it means that our cosmic journey has a direction, a purpose written into the very laws of physics. It's a perspective both humbling and inspiring. We are small on a cosmic scale, but we have the extraordinary ability to decipher the deepest secrets of reality. Now, I want to hear from you. What do you think about this possibility that the universe has a preferential direction? Would it change your perspective on our place in the cosmos? Leave your thoughts in the comments. I love reading the brilliant ideas from our community of cosmic explorers. And since we're talking about cosmic mysteries, what enigma of the universe would you like me to talk about in the next video? Primordial black holes, the nature of dark energy, the Fermi paradox. Leave your suggestions in the comments. We're on an incredible journey towards 1,000 cosmic explorers. If this video sparked your curiosity about the universe and made you question your assumptions about reality, join our crew by clicking subscribe. Like this video if it expanded your cosmic horizons, and share it with someone else who also loves the mysteries of the universe. In the next video, we'll explore another fascinating enigma that's baffling scientists. Until then, keep looking at the stars and questioning everything. The universe is full of secrets waiting to be discovered, and together we are breaking through these cosmic frontiers, one discovery at a time.